Welcome to the video on one-sample hypothesis tests. I am Dr. Ellen Gordon. In this module, you will learn how to conduct two statistical tests or hypothesis tests, a one-sample z-test and a one-sample t-test. However, first it's important to learn the basics of hypothesis testing. In this video, I will introduce you to hypothesis testing and I'll teach you how to write hypotheses. In the following videos, you will learn how to conduct the statistical or hypothesis tests in Excel. Hypotheses are expectations or questions about the population of interest. For example, as a COB instructor, I might think or have an expectation that business graduates have a higher starting salary than the average OU graduate. Hypothesis testing is a statistical process used to test hypotheses about populations using samples. So in my example, I can take a sample of 50 COB graduates and ask them what their starting salary is. I can then use that sample mean to make a conclusion or inference about the population mean of all COB graduates. Hypothesis testing is also known as inferential statistics. It's very important to point out that the purpose of these tests is to draw conclusions about the population. I really care about the average of all COB graduates, or what the population mean is of all COB graduates. However, it may be difficult to get that information from all COB graduates. I might not have access to them. However, it's fairly easy to get a sample, so I'm going to use a sample mean. So I'm going to use a sample mean or statistic to make a conclusion about the population mean or parameter. So again, hypotheses are really questions or statements about populations and not samples. However, we use sample data to test our hypothesis. There are many different hypothesis tests. In this module, you will learn two: one sample Z and one sample T. But first I'll teach you how to write hypotheses. For every single test, there are two hypotheses that you need to write: the null and the alternative hypothesis. The alternative hypothesis is denoted as H1. This is the research hypothesis. It is the hypothesis that the research is designed to investigate. For example, if I have an expectation or prediction that COB graduates have a higher average starting salary than the average OU graduate, this would be my alternative or research hypothesis. For one sample test, which is what is being covered in this module, the alternative hypothesis is investigating a mean difference between two groups. So in this module, we will be comparing two group averages. There are three different possible alternative hypotheses. A test is called a one-tailed right if the alternative hypothesis is that the group of interest mean is greater than the other group's mean. For example, if we predict that COB graduates, which would be the group we're interested in, has a higher average starting salary than the average OU graduate, we would call that a one-tailed right test. A test is called a one-tailed left if the alternative hypothesis is that the group of interest is less than or lower than the other group's mean. For example, if we predict that COB graduates have a lower average starting salary than the average OU graduate, we would conduct a one-tailed left test. We call a test two-tailed if the alternative hypothesis just states that the two groups or populations are different. Let's say that we don't have a specific hunch or expectation that COB graduates make more or make less. We just want to explore and see if there's a difference. If that's the case, our alternative hypothesis would be there's a significant difference between the average starting salary of COB graduates in comparison to the average OU graduate. We aren't specifying that we think COB graduates make more or make less. We're leaving it open-ended. We just want to see what the difference is. We would call this a two-tailed test. The null hypothesis is denoted HO. The null hypothesis is the hypothesis of no significant difference. This hypothesis states that there's not a mean difference between the two groups. So for our example, the null hypothesis would be there's not a significant difference between the average starting salary when comparing COB graduates to the average OU graduate. You might be wondering why we have a null hypothesis when we're really interested in our alternative or research hypothesis. The null hypothesis is very important. In fact, hypothesis testing really only concerns or examines the null hypothesis. And the reason why is the null hypothesis is much easier to test. The alternative hypothesis is very ambiguous. Think about it. If we predict that COB graduates make more than the average OU graduate, well, how much more? How big of a mean difference do we predict? 5,000? Do they make 10,000 more? 20,000 more? It would be very difficult to predict an exact mean difference. Instead, we just write an ambiguous research hypothesis that doesn't specify the exact mean difference. However, that makes it very difficult to test with data. However, the null hypothesis is concrete and objective. It states there's not a difference. Thus, we predict a mean difference of 0, and that's very easy to test. So the results of a statistical test only concerns the null and not the alternative. These tests are going to tell us either to reject or accept the null hypothesis. However, when we reject the null, we accept the alternative. Thus, rejecting the null offers indirect support of the alternative hypothesis. We will return to this concept in later videos when we cover our first hypothesis test. Okay, so let's summarize what we've learned. We'll use the example that the population mean starting salary for OU graduates is $50,000. We have a sample of 50 COB graduates. If we conduct a one-tailed right hypothesis test, the null hypothesis would be that there's not a significant difference in the average starting salary when comparing COB graduates to the average OU graduate. Here is a visual depiction. Again, the null hypothesis is stating there's no difference. They have the same mean, so these two populations would have the same distribution. The alternative hypothesis is that COB graduates have a significantly higher starting salary than the average OU graduate. Here's a visual depiction of the hypothesis. You can see that the mean for COB graduates is greater than the mean for OU graduates. They belong to different distributions, and the distributions for COB graduates, which is our group of interest, is to the right of the OU distribution. If we conduct a one-tailed left, again, the null is the same. There's not a significant difference between COB and OU graduates. They have the same mean or distribution. The alternative is COB graduates have a significantly lower starting salary than the average OU graduate. And in the visual depiction, you can see that the mean for the COB graduates is less than and to the left of the OU mean. And now for a two-tailed test. Again, the null is the same. There's not a significant difference between our two groups. The null is always the same. However, since it's a two-tailed test, the alternative is that there is a significant difference in the average starting salary when comparing COB graduates to the average OU graduate. So we think that the population mean for COB graduates is either less than or greater than the mean for the OU graduates. So there are two possibilities. We can also express hypotheses in symbols. In the previous examples, the hypotheses were communicated in words. However, oftentimes researchers will use symbols in place of or in addition to written hypotheses. For a two-tailed test, the alternative hypothesis is the mean for COB graduates does not equal the mean for OU graduates. Remember, for a two-tailed test, we think that the two means are different, so they're not going to be equal. This symbol is the Greek symbol mu, and it stands for population mean. The null is the mean for COB graduates equals the mean for OU graduates. For a one-tailed right, the alternative or research hypothesis is that the population mean for COB graduates is greater than the population mean for OU graduates. For the null, we would say that the mean for COB is less than or equal to the mean for OU graduates. When we write the hypotheses in symbols, the two hypotheses have to be collectively exhaustive. In other words, the two together have to cover all possible outcomes. If the mean for COB isn't greater than the mean for OU, then it would have to be less than or equal to. For a one-tailed left, the alternative hypothesis is that the mean for COB is less than the mean for OU. Thus, the null would be the COB mean is greater than or equal to the OU mean. When writing the hypotheses in symbols, I recommend starting with the alternative hypothesis and then figuring out the null. And the null in symbols is basically the opposite of the alternative. Also, note that the null hypothesis always has an equal sign in it. Please open your prep file. You'll notice in the prep assignment that there's part 1 questions and part 2 questions. I'm only going to cover the part 1 questions. You'll do the part 2 questions on your own. So after we go through these questions, make sure that you finish all of the questions on the sheet. If you're having difficulty answering the questions in part 2, please review the lecture component of the video. The first question reads, a department store knows that their average customer spends $96 with a standard deviation of $29. A study was conducted to determine if people who pay for store purchases with a credit card spend more than the average customer. An analyst took a sample of customers who paid with a credit card. When answering these questions, I think it's the best to first identify the alternative hypothesis. Again, the alternative hypothesis is the research hypothesis. It's the focus of, or it's the purpose of why they're conducting the study. I think that's the easiest to identify. So they want to look to see if people who pay for store purchases with a credit card spend more. So that is our alternative hypothesis. And you can see right here, it's C. People who pay with a credit card spend significantly more on average in comparison to the average customer. So we would put C. Then we can think about the direction of the test. Remember, that goes along with the alternative hypothesis. So we would do a one-tailed right? When we think our group of interest, which is credit card customers, we think that their mean is going to be greater than the other group. That would be a one-tailed right. And then the null hypothesis is easy. The null hypothesis inwards is always the same, and it's always there is not a significant difference between the two groups. So that would be A. And next we're asked about the hypotheses and symbols. And again, I think it's the easiest to start with the alternative hypothesis. The alternative hypothesis is we think the mean for credit card customers is greater than the mean for all customers. So that would be C. And then the null hypothesis in symbols is just the opposite of that. So if it's not greater than, it would be less than or equal to, and that's going to be the null. So that would be F. Remember, the null hypothesis in symbols always has an equal component to it. The next question, a human resources department wants to determine if there is a gender difference in terms of job satisfaction at their corporation. They know the population mean for male employees is 8.3 on a 10-point scale, and they take a sample of 50 females and assess job satisfaction. All right, so what is the alternative or research hypothesis? There's nothing in here where they think that males have higher job satisfaction or females have higher job satisfaction. They're just looking to see if there's a gender difference. So they're exploring it. They want to see if what's going on, if it's males are greater or females are greater. So that would be a two-tailed alternative hypothesis. So they're just going to state that they think or predict that there is a significant difference when comparing males and females. And again, that would be a two-tailed test. A two-tailed test is when it's very open-ended. You don't want to specify which group is greater because you just want to explore to see if there is a difference. And again, the null hypothesis is always there is not a significant difference between the two groups. All right, the hypotheses in symbols, again, we'll start with the alternative. We think that there is a difference, so that means that the means are not equal, right? If they're different, they're not equal, and then the opposite of that would be that they are equal. All right, moving on to the next question. It reads, at a consulting firm, the current project completion time is 15 days. They are wondering if a new software package will provide a shorter project completion time in comparison to their current technology. So starting with the alternative hypothesis, they think that it provides a shorter completion time. So out of all the options, that would be C. The new software leads to a significantly shorter average project completion time. And that would be a one-tailed left, right? We think that the mean for the new software is less than the mean for the current technology. So it's less than, it's going to be to the left, one-tailed left. And then the null hypothesis in words, easy. It's always there is not a significant difference. Moving on to the hypotheses and symbols. So we'll start with the alternative. We think the mean for the new technology is going to be less than the mean for the current technology. So that would be D. And then the null in symbols is always the opposite of whatever the alternative is symbols. So it's not going to be less than, it's going to be greater than or equal to. And remember, the null in symbols always has the equal component to it. So that would be E. All right. The next question reads, the U.S. Department of Transportation provides the number of miles that residents of the 75 largest metropolitan areas travel per day in car. A researcher wants to determine if Buffalo and Boston residents differ in terms of their length of daily travel. The population mean commute time for Boston residents is 18.6 miles a day, with a standard deviation of 7.4. A simple random sample of 50 Buffalo residents determined the mean is 22.4 miles per day, with a standard deviation of 8.4. So let's think about what our alternative hypothesis is. So they want to determine if the residents differ in their terms of daily travel. So the researcher isn't predicting that they think Boston residents travel more or Buffalo residents travel more. So this is going to be a two-tailed test, and they're just looking to see if there's a difference. So that the correct answer would be B. A lot of times when people read this, they think that it's actually a one-tailed right, and that the alternative hypothesis would be that Buffalo residents travel more than Boston residents because they see these means and Buffalo is greater than Boston. However, it's important to note that hypotheses, the research hypothesis, is your prediction, and you determine your prediction before you compute the means or before you look at the data. So the researcher comes up with this hypothesis and then they look at the means. So when you're trying to determine the hypothesis based on this little synopsis of the research, make sure that you're basing it off of what the purpose of the study is or what the researcher thinks is going on and not the data. So again, the alternative hypothesis is two-tailed. The null hypothesis in words is there's not a significant difference. The null hypothesis in words is always the same. Moving on to symbols. The alternative hypothesis is we're looking for a difference. So that means we predict that the means are not equal. And the opposite of that would be that the means are equal. So the null would be B. You can see that there's questions for part 2. Please answer these questions on your own. If you're having difficulty, again, please review the lecture component of this video.